Initial part are a couple of pip installs that you are required to do. So first we need to do a pip install of datasets, and don't worry too much about these things. So datasets is basically a Hugging Face library. We introduced something called Hugging Face yesterday. Hugging Face is a very popular open source community of data scientists, machine learning engineers, Gen AI developers. So anything and everything to do with AI and data. So that entire community, Hugging Face is one of the biggest communities out there. So a lot of people contribute data sets, models, everything there. So we actually have a Python package for that as well. So we can download data sets, pip install data sets, and this way we can actually take data right from Hugging Face. Can you see? It's actually getting installed. So now we can do the rest of the stuff. We already did part of this in yesterday's session. You are already able to install the secrets yesterday, and whatever secrets you installed yesterday will already show up. You do not have to do this today again. Okay, so you already did the secrets part yesterday, Azure API key and all this. So this is the same collab, this is the same account that you're using, right? So against the same collab, against the same account, this will come up. There'll be no difference here, right? So I will just load the API key. The endpoint URL and all this is the same. Okay, this is all the same, right? This will not change. This is for me, but for you, remember, you will have to change your endpoint URL, and you already know how to do it. You already know that you can go to view code, you can take the endpoint URL, and you can modify it. Okay, so this is just one thing you need to keep in mind. Just make sure in all these notebooks that I share, you just go and modify your endpoint URL. Okay, so this is just a basic initial setup that I'm doing. Rest, there is nothing much to talk about. This is the same workflow that I discussed already. And now we will just see a simple code example of the same. So first, let me show you the data. What type of data do we have here? Right? I'm taking a simple Amazon use case, and this is my data. This is my data. All of you can see. So we have the content and we have the label. The content is nothing but the actual review. This is a long review a customer has written. So the content is a long review the customer has written, and the label is basically the sentiment. Is it positive? Is it negative? Is it positive? Is it negative? That's the idea. Okay. And you can see it's obvious that the zero means sentiment is negative, because I think the third review is talking about problems. The user was not happy about the purchase. The third review talks about problems. So the sentiment is kind of negative for the third review, whereas the fourth review, the sentiment is kind of positive, because the label is one. I think the user was very happy about it. Okay, so we already have this data, and see how we already have kind of split our data into training and a few shot and gold examples. This is already done, right? So it's already done. So we've already split our data into few shot and gold examples. And here we have actually split equally, although in a more real world application, the split will not be equal. So as I told you, you will have a very small percentage of data for few shot, and like majority of your data will be part of gold, because gold is very, very important. LLM application evaluation is the most important part. You need to keep a substantial amount of data aside for evaluating the LLM models, how they are performing. Okay, so here it is already done. You can see the split is already done here. So we have something called example reviews, review examples DF and review gold examples DF. DF is nothing but data frame. Okay, so now that is done. So this is a simple prompt that we have right now. The system message: classify product reviews in the input as positive or negative based on sentiment. Do not explain your answer. Your answer should only contain the label 1 positive or 0 negative. You can see how we are explicitly stating that given the review, please output either this or this. Do not explain your answer. Don't explain the reason why you gave me something. Just output either it is positive or it is negative. That is all we want to see. We just want to see the output, nothing else. You're explicitly specifying that. You're explicitly stating that. Okay, and now we are actually curating the. So we are actually curating this thing. We are curating the examples now. This is a bit of Python that we are doing. So again, I mean, so all that we are doing is we are basically appending the few shot prompt. So you can see we are taking a sample of 4. So all that we are doing is we are basically assembling a few shot prompt with 4 examples. So that is all that we are doing. Okay, we are assembling the few shot prompt with 4 examples. This is just a little bit of Python code that we've written, where you can see we already have something called Amazon reviews examples DF. So we're iterating through all the rows. We are going through all the rows of my data frame, and we are appending the user and the assistant examples. So we already have this, right? So we are simply curating the prompt this way. Maybe if I show you the output, it will be a lot clearer. If you see the output, this is what we curated. So we went through all the four rows, and we took actually sample of four. That's why we created four pairs. Okay, if you want to see the four pairs right now, what are the four pairs? User assistant, user assistant, user assistant, user assistant. So can you see the four pairs that we got? These are the four pairs that we got. Okay, so this is the first user assistant pair, UA. This is the second user assistant pair, UA. This is the third user assistant pair, UA. And this is the fourth user assistant pair, UA. So these are the four few short examples that we have. And at the top, you can see the system message. So this is what I was talking about. This is what you curate. This is part of your prompt design. And this is just iteration one. Now, let's say with this prompt, I will query the LLM model and I will see what kind of predictions it is giving on the new data. I will evaluate the model. And let's say if I'm not happy, what I will do is I will go and change the system message. I will go and take more number of sample examples. Let's say in this case, I will take 8. I'll take more number of sample examples. And then if you take 8, you will get a bigger prompt. Can you see? If I take 8, I'm actually getting like 8 few short pairs. So this is something that you have to try out. You have to iterate and you have to try out. You have to try out different examples and see what works generally. Okay, actually, this is adding on top of it. So I need to first go and kind of take the few shot and do it again. Okay, yep. I think I initialize a variable somewhere here. It's actually a list, right? So anyways, let me just do it from the top. Yeah, it's a list. So because I'm appending, so it will actually start from here. So I have to actually, because this is a list. So when I do append, it is just adding on. So even if you change it to sample 4, sample 8 is simply the appending to a list. So you have to run this code again. You have to run from here again, and then it will work fine. You can see I'm back to the 4 few short examples which we originally did. Okay, and now we will look at LLM evaluation. So we have predictions and ground truths. Predictions are basically the predicted sentiments, and ground truths are basically the gold examples. What are the actual sentiments, the gold examples? Okay, so straightforward, and we can let the model work. I'm not taking you line by line through the Python code because I mean this is all basic Python. So you can see what we are doing is we are going exactly what I explained in the theory. So now you're going through every single row of the gold example, and you're taking a new user input. This is the part where you take a new user input. See, this is the gold review. So you take the gold review, which is nothing but the user input. And now inside the try catch block, you are actually doing a chat completion create. So you already have the few short prompt. And on top of the few short prompt, you add your new user input. You add your gold user input. And based on that, you get a predicted response. The response is nothing but the predicted response. And this you continue appending to the predictions list. And and at the end, what you do is you go and compare the predictions list with the ground truths list, and you get an accuracy score. This is all that we are doing. This is take a little time because remember we have a lot of text. We have a lot of text, and at the end of it all, you will see an accuracy score. And after you get an accuracy score, what you can then do, you can go back to the system message. You can modify your system message a little, and then you can again come back down and you can see the accuracy score. And this is how you will iterate. This is actually what prompt engineers will do. The next time when we hear the term prompt engineering, a lot of people get confused. Okay, what are they really doing? This is the kind of work they're doing. They're trying to modify the system message. Because remember, in the front end application, when you're using any front end application, even something like Chat GPT, which is so ubiquitous now, it's so common in every household now. Okay, it's a household name today. Everybody knows it, right? So we have no idea what the prompts are. We have no idea what the system message or the prompt template looks like. We have no idea. We are only giving the user inputs. Okay, but the makers of Chat GPT, they would have spent a lot of time. They would have tried different system messages. They would have also given some few short examples which we have no idea. We have no idea what kind of parameters and everything they have given. So they would have also done a lot of these customizations, and they would have evaluated their prompts, and they would have deployed the final one. Okay, that's the idea. Very interesting. You're also getting an error code. You can see 400. 400 is an error code which says this is actually fine. The system will not error out because it's a try catch block. So maybe there was some review that got errored out due to the content management policy. And if you just see, this is one of those reviews that got errored out. You can see which part where the error happened. You can see content filter was triggered, and which part of the content filter was triggered. Hate, no, this was not triggered. Filtered false. Jailbreak, filtered false. Jailbreak was not triggered. Self harm, filtered false. and maybe sexual is filtered true. So maybe this was some abusive comment or something people wrote. Let's say you purchase something on Amazon and you write some abusive comment. So this is the content management thing that was triggered. Okay, but because we are in a try-catch block, only that row will be ignored, and the rest of the records will be processed. Okay, so this is another very interesting thing that you can see. You can actually go and see step by step which of the records are getting ignored. Okay, yeah. Anyways, for the rest of the predictions will work fine. So every new user input is going through the API. We are getting a predicted sentiment, and now we will compare the predicted sentiment with the actual sentiment. And if we get a high score, we can be confident that yes, our prompt is good. We have designed a good quality prompt, which is ready to deploy. We'll just wait for this to complete in a minute. Let's see, because you have to understand the context. Like the number of tokens is massive. So the moment you start building applications at this scale, and we'll see a big part of this today also, you'll start to see the amount of token counts is huge. You're talking easily about crossing 1,000 to 10,000 tokens now, because there's a lot of text. Every review is very big actually. If you just open it up and see in detail, that's why it's taking time. And it is complete now, and you can see we're getting a 96.774% accuracy, which is quite good. 96.774% accuracy we are getting, which is a pretty good number that we are getting right now. Okay, now you can, what is iteration 2, what you can now try to do is we can go back and make some modifications in the prompt, and we can again run it, and this is how we can test out our prompt templates. Okay, and if you come all the way down, what we have done is something called a classification report. Now this is again some people who are coming slightly from a traditional AI and machine learning background can relate to it. So not only can you get the full score, but you can also go back and in a way uh, find out the class level performance. You can also build something called the confusion matrix. You can see, okay, what is the performance of only the negative class, and what is the performance of only the positive class. So you can look at things like false positives, false negatives, true positives, true negatives, and you can see the class level performance, right? So at a very high level, I'm not getting too much into the theory of all this right now, but at a very high level, you can think of using something called an F1 score, and you can look at the class level accuracy. So here the overall accuracy is 97%, which is anyways very good. But not only can we see the overall accuracy, but we can also see the class level accuracy. This is like a weighted accuracy. F1 score is like a harmonic mean of precision and recall. But anyways, at a very high level, you can use an F1 score to gauge the overall quality of the model on an average, right? So you can see the class level performance. And why it is important is because, see, here it doesn't, like, maybe it's not that useful because we only have two classes, either it's negative or it's positive. But then if you have a multi-class classification, if there are multiple categories, like let's say typically for a document management system that a lot of enterprises are using, you might have a very real world classification task. So you are having a lot of document data, and based on an automated system, you want to categorize documents into different types. Okay, so let's say based on the text of the document or based on the title of the document, you want to categorize the documents into different types. And you have 10 different document types. Okay, type 1, type 2, type 3, type 4, up to type 10. Okay, or it could be also related to support tickets. So you've got 10 different classes of support tickets that the support ticket can be classified into. So based on the ticket message, based on the support ticket message, you want to classify what category the support ticket belongs to. Is it a category 1? Is it category 2? Is it category 3? Is it category 10? So that's the problem that you are trying to solve, let's say. And there you will have an overall accuracy that is fine. But what will be also very important to see is what is the individual class level accuracy. You also want to know that how is the model performing with respect to each of the types. So I want all the types to do equally well. I don't want type 1 to do like 100%, but type 2 to be like only 10%. That is useless. So the classification report gives you a very strong understanding in terms of how individual classes are performing, not just the overall how it is performing, but also how the individual classes are performing. And that can also help you in debugging, and then you can do a root cause analysis and all those things specifically with respect to that class. So if you see, let's say the type 2 type of documents are not getting categorized correctly, let's say the accuracy is coming out to be around 10%, the F1 score is around 10%, let's say, then what you can do is you can now explicitly look at the type 2. What is going wrong? Why is the language model unable to categorize the type 2 documents correctly? What is going wrong? Maybe it could be that, okay, type 2 is very similar to type 4. Maybe the text in type 2 is very similar to type 4, something like that. Maybe there are two products that your company is using which are very similar. So the LLM model is unable to differentiate between what is type 2 and what is type 4. So that's why a lot of mistakes are happening, a lot of false positives are happening. Okay, so and these are very, very good ways to kind of figure out. And maybe if that happens, maybe the next step could be you can combine type 2 and type 4 together. So no need to have them as separate categories. So maybe at the company you decide that, okay, we don't need to have 10 different document categories anymore. So because type 2 and type 4 are getting confused because they are so similar, because these two products are very similar, uh, we don't need to have separate categories for type 2 and type 4. Let's club them together and call it type 2 4, whatever, something like that, type 2 4 combined. All right. So this is demo number 1.